Welcome to the Developer Service YouTube channel. On today's video, we're going to be talking about comparisons in Python. There's specifically three types of different comparisons in Python. You can do pure comparisons, you can do if and else statements, and since Python 3.10, you can do pattern matching. Let's take a look in more detail what each of the comparisons means. So the most basic way of comparing in Python is by doing pure comparisons, which can be the greater than or smaller than or the equal signs. So in this case here we are checking if A is smaller than B, and in this case we are comparing if name is equal to Alice. So if I run this code, you can see that A is less than B, and you can also see that it says hello Alice. If we change here and we change for instance for different here, and we change for here greater than, then if I run it again, you see none of the conditions match. So pure comparisons, it's the simplest type of comparisons, and it uses normally the arithmetic operators to do the comparisons, and it's very straightforward and very easy to use and similar to in Python to any other programming language. What are the pros and cons of the pure comparisons? In the pro side, it's simple and direct for basic value comparisons. It has a very clear and concise syntax. On the con side, it is limited to very simple data types, as integers and strings, for instance. It's also not suitable for unpacking or inspecting complex data structures, because it's a very simple type of comparison. So let's now move on to the next phase of comparisons. We have the if and else statements, and those of course can use the pure comparisons also. So in this case we are using equals, and we're using the if. So we're checking if this value is equal to the 1, 2. We're also using the if in case that value is not correct. We're checking doing another if and checking another condition, and else if none of the previous conditions are true, then that will happen. So if we run this code, I can see that it says exact tuple match because the value corresponds to 1 and 2. Of course, if we change this to 1 and 3 and we run the code again, now it will say that the tuple starts with 1 because the first if condition was not true, but the second if condition was true. And if we change also the first value and we run the code again, then we have no match found. So that's how you can use if, else, and if, else if, and this and else with together with the pure comparison type of operators to establish an if and else statement. What are the pros and cons of the if and else statements? Well, on the pro side, it's very familiar and widely used in many programming languages. It is flexible and works well with a variety of conditions. On the con side, it can become quite verbose with nested or complex conditions. It requires manual data extraction when dealing with some structured or nested data. So since Python 3.10, we can actually now do pattern matching, which means that we try to match a particular value to a particular case or to a particular condition. In this case, we're trying to match a tuple, and so when we can do direct match if it is the case of direct match. You can also do that it starts with 1. So the underscore means that it can have any value in the second point. And replicating an else statement in case of underscore, then that means that no matching is found. If we run this code, we see that it says it's an example tuple match, similar to what we saw in the previous example. If I change this value and run the code again, so it's going to say that the tuple starts with 1 because it starts with 1, and any character can be in this position. And if I change both values and I run the code again, then it's going to say no match found because it's the else condition. It does not match the exact. It does not match starting with 1. So it is an else statement, or a case replicating an else statement, no match found. The pattern matching can also be used with more complex examples, and it can also do data extraction at the same time that we are doing the comparison. So in this case, we have a point, which is a dictionary with an x and a y value. We're trying to match that point, and we're going to define a case where the x and the y is a condition, and at the same time we're extracting the x and the y that we can use in the print statement. In case it's not a point, then it returns that it's not a valid point. So So if I run this code, you can see that it compares that is this exact structure in the dictionary, so that it has an x value, an x with the value and a y with the value. It at the same time returns those x and y values in the x and y variable, and so it can print out that the point has the coordinates x equals 10 and x equals 20. And if I change the first one, you'll see, and if I run again, it still matches the coordinates because it has the x and the y, and it returns the 15 and 20. If I remove, let's say, the y from the point, and now if I run, so it will not be able to match. If I run the code, it says it's not a valid point because it does not have a dictionary with an x and a dictionary with a y. And that's a more advanced use of the pattern matching, which allows to extract the values at the same time that is doing the comparison. So what are the pros and cons of pattern matching? On the pro side, it simplifies the handling of complex and nested data structures. It provides a clear and concise declarative syntax, and it reduces the bother code when you need to extract the values as you just saw. On the con side, it's only available in Python 3.10 and later, obviously. It requires a shift in mindset when you're used to doing the traditional if and else chains, and the new syntax can be a bit less intuitive, at least until you become familiar with it. After that, it becomes quite powerful. So if we summarize and compare the different techniques, when should you use pure comparisons? Well, they're ideal for simple and straightforward values checks. For example, if you're checking if a variable equals a specific number or if a string equals a specific predefined string. On the other side, when to use if and else statements, they're ideal for sequential decision when using multiple distinct conditions that need to be checked. For example, when you want to handle multiple logical branches where each branch has a different property of the data itself. And for pattern matching, that is ideal when you want to inspect and deconstruct complex and nested data structures. And a very clear example of that, if you're processing JSON-like dictionaries or tuples, as we saw in the examples, or even custom objects where the structure of data is as important as the value that you want to compare with. Thank you for watching. Like this video if you like this content, and subscribe to the channel for more content about Python, Django, and AI. And until next time, happy coding!